So let's do an example. Make sure you understand the concepts, go through some mechanics. So here's a random part, part number VMI1984, and we want to develop monthly forecasts in pallets for this item, VMI1984, and it seems that the item has an upward trend. So there's a trend here and a level. And looking at past year's data, you've determined that you're going to use an alpha of 0.25, a beta of 0.1. And your estimated level A hat 0 in January, which is time 0, right, is 28 pallets per month. That's your most recent estimate of what the level is. And your most recent estimate of the trend is 1.35. So you're assuming an upward trend of 1.35 additional pallets each month. So what do we want to do? Well, using exponential smoothing, Holt's method, which means we're going to look at a level and a trend, we want to estimate the forecast for February. And so this is easy. You're just going to plug and chug here, because my x hat j comma f, which is the forecast in January, at the end of January, for February, is going to equal to my estimated level in January plus 1 month times the estimated slope of the trend, which is the b hat in January. So I give you all this, right? My estimated alpha is 28. Gave that to you up here. I'm going 1 month in the future, and I'm going to do my estimated trend in January, which is 1.35. So I'm just adding them together, and I get 29.35. All right, let me clean this up. Now, what we want to do is say, okay, it's the end of February, and demand came in, it was 27 pallets. So now what's your forecast going to be for March? Now we could do this by hand again, but we're going to use a spreadsheet. Now I know in real life when you go work for a company, you're probably not going to be doing your actual forecasting using a spreadsheet. But we're going to use them in this class because it helps you understand the mechanics and the concepts a lot better. And it's easier than doing everything by hand, by pencil and paper. And it helps you see some other aspects of it as well. So here's a spreadsheet, and again, this is in the resources link for this video. And this is the spreadsheet, and you see I've got columns A, B, C, all the way to H, and rows 1 through 6. My alpha value of 0.25 is in cell B1. My beta value of 0.1 is in cell B2. So what do I have here? Well, each of the columns is a different value. So the column B is the T's, the time period, 0 and 1. I just list 2 here. We'll show more in a second. XT is the actual demand in time period T. So this is the 27 units that appeared in, or 27 pallets rather, that showed up in February. Column D is the estimate of the level at that time T. You see the 28 and the 1.35 from what I gave you in the problem. And then the X hat, T comma T plus 1, is the next period forecast, and we just figured that out, 29.35. But what we wanted to figure out was this term in F6. So how did I figure that out? Well, first, this 29.35, like I said, it just came from adding the estimated level, which is in cell D5, plus the estimated trend of 1 period in E5. That should be pretty obvious. But to find the forecast in March, I want to add together the estimated level in February plus the estimated trend in February. How am I going to do that? Well, I'm going to update. My updating equation for the A term is going to be alpha, which is in cell B1, right, this 0.25, times my most recent observation, which is in cell C6, which is this 27, plus 1 minus alpha, times F5. What's in F5? My most recent forecast, this 29.35. So that's what the 28.76 is. It's the linear combination of those two numbers, the new information and the old information. My update for my trend is the same type of thing. I'm going to take my beta, which is in cell B2. So it's beta times my most recent trend estimate in D6, that's that 28.76, minus my most recent before that estimate of the level, which was up here in cell D5. So 28.76 minus 28 is 0.76. That's my new estimate of the trend. So it's lower than what I had estimated in January, which was I had estimated before at a 1.35, which is shown right here in cell E5. So I'm going to take that new estimate, the D6 minus D5, and multiply that by my beta, and add 1 minus beta times that value in E5, which is my most recent estimate of the trend. So it goes straightforward, and so my forecast for March sitting in February is what's here in cell F6, 30.05. So again, it's very mechanical. You take the new information, multiply it by the alpha or the beta, add in the old information, multiply that by 1 minus the alpha or the 1 minus the beta, add the estimate for the level and the trend, and that's your forecast. Now, what about my error term? Well, that's over here in cell G6. So what is this saying? This is saying in February, my error term is going to be equal to what I actually had demanded in February, which is 27 in cell C6, minus what I estimated to happen sitting in January, which is this 29.35, sitting up here in cell F5. So 27 minus 29.35 means my error is 2.35, or a negative 2.35. Column H, I just square it, right? Square error, because that's one of the metrics that we're going to look at. So this is pretty straightforward. But now let's suppose I want to go a step further. And for the same item, for the same demand, I want to build a spreadsheet for the next month estimates for the next 8 months. So everything's the same here. I've got my alpha term, my beta term. I've still got my T period 0, 1 through all the way to 9. I've got column C tells me my actual demand. And then column D gives me my current estimate of my level. And column E gives me my current estimate of my trend. And now obviously if I'm sitting in March, right, and I'm making estimates here, I don't know all of this stuff yet because that hasn't happened yet. But what I'm showing here you in this spreadsheet is at the end of these 9 months. So here in column C is the actual demand, and then these values in column F are my next month forecasts. So sitting in, let's say, June, right, my forecast for July is going to be 35.29. That's the X hat T, June, for T plus 1, July. So that's my estimate for 35.29. All right. Now, one of the things that we're going to do is look at the quality of the forecast, because remember, we don't want to do just a point forecast. We always want to track what my error is to give some kind of sense of the range or the variability of my forecast. We'll be using this a lot when we talk about inventory. So if I look at the mean square error, remember that's just the sum of the error terms divided by n. I want to pick one, but which one do I pick? So how far back do I do? Do I go back to the most recent one? It's not clear how I'm going to find this mean square error for all of my terms, because it might change every time I get a new month. So what you might want to do is use, believe it or not, a smoothing method to find out a nice calm level of what a mean square error is. And so you can use this in your other forecasting or in your other inventory planning models. So let me show you what this means. We're going to keep a current running update of the mean square error, and that's what's shown in column I, and I'll explain that in a second. And we're using exponential smoothing because it's our friend. Okay, we're going to select an omega, and that's my smoothing term. And omega is between 0 and 1. Again, we're just going to do a linear combination of two values. And you guessed it, my mean square error in time t is going to be equal to omega times my most recent estimate of the error, which is my most recent forecast, xt, minus x hat t minus 1t, which is my most recent forecast. This is also known as the most recent error term. And I'm squaring that. So it's omega times the most recent error term squared, that's the new information, plus 1 minus omega times my most recent forecast or estimate of the mean square error. So let me show you what this looks like for the October estimates for the mean square error. And what this is saying here is this 4.52 is simply the linear combination between this H1, cell H1 is my omega value, and I picked a 0.05, and that's going to be multiplied by the value in C14, which is my most recent value that showed up, my most recent demand observation, minus what's in F 13, which is right here, which is my most recent forecast of that. So I forecasted 37.10, 36 showed up. So that's going to be what? 1.1 squared multiplied by that omega term, again that 0.05, add to that 1 minus omega times what? This term, my most recent estimate of the mean square error. So in this case, what we're doing here is, again, we're using smoothing and we're putting a very low value on it, on the omega. Why? Because we want a calm forecast here. We want a calm estimate of the mean square error. We'll be using this mean square error of the forecast a lot in a couple lectures, in a couple lessons. But I just wanted to show you how you can use exponential smoothing in many different situations, and we'll use it again in the next video as well. But this tells you some of the mechanics of how to do forecasts within a spreadsheet. And whether you have a more sophisticated package, at the heart of it, it's doing the same calculations.